Welcome Algebra 1 students to another Regents review video. This is the Algebra 1 Common Core January 2017 Regents exam, and these are going to be the solutions to parts 2 through 4. These are the open-ended free response questions that requires your work. And speaking of work, make sure that you do your own work. Do not cheat off of this video and call them your own and hand them in for homework. It's really in your best interest to try the problems on your own, then come back and seek assistance. But if you're here to check your answers, fantastic. And if you were here for a little assistance, that's fine as well. Hit that subscribe button down below and make sure that you visit my website at www.nysmathregentsprep.com. That link is in the description below. And just a reminder that I use the TI Inspire CX calculator. It is one powerful calculator, and I highly, highly recommend it. The link is on my website to Amazon. All right, without further ado, no time wasting, number 25, here we go. In attempting to solve the system of equations y equals 3x minus 2 and 6x minus 2y equals 4, John graphs the two equations on his graphing calculator. Because he saw only one line, John wrote that the answer to the system is an empty set, meaning that there's no answer. Is he correct? Explain your answer. Well, here we go. We have y is equal to 3x minus 2. Let's go ahead and convert this into y equals mx plus b form. So we get 6x minus 2y equals 4, right? I'm going to subtract the 6x on both sides. We get negative 2y is equal to negative 6x plus 4. We divide by negative 2 on both sides, right? So we get y is equal to positive 3x minus 2. All right, that's it. Whoa. Wait a minute. Huh? These are the same line. So, John said that it's an empty set. He's incorrect because this is the same line. So, of course, he's not going to see it. Now, listen, if he had a colored calculator, that'd be awesome. He could kind of see it. If you graph 3x minus 2, it's a blue line. And then if you graph it again, 3x minus 2, it's a red line. It's overlapping each other. This is actually infinite. These show infinite solutions. So when John says that there's no solutions, we're going to say, nope. John, you're wrong. So John is wrong because these equations are the same line. The solution set is not empty. In fact, there are infinite solutions. And that is your answer. All right, that's how you do question number 25. Moving on to 26. Here we go. A typical marathon is 26.2 miles. Alan averages 12 kilometers per hour when running in marathons. Determine how long it would take Alan to complete a marathon to the nearest tenth of an hour. Justify your answers. So, we have different units. We need to use our reference sheet. So, we're trying to find, let's see. A typical marathon is 26.2 miles. He averages 12 kilometers. So, if you go to your reference sheet, which is up here somewhere, on the reference sheet, it says that 1 kilometer is equal to 0.62 miles. So we need that. We need that badly. So 1 kilometer is equal to 0.62 miles. So here's step 1. This is what we need to do. Step 1. We need to convert the 12 kilometers into miles per, just 12 kilometers into miles. So, how do we do that? Well, we need to take 0.62 kilometers. No, I'm sorry, 0.62 miles, I should say, miles. Yeah, 0.62 miles over 1 for 1 kilometer, because this is all miles over kilometers. So 1.62 miles over 1 kilometer, that is equal to x over 12 kilometers. So how many miles are there in 12 kilometers? So 12 times 0.62, that means that there are 7.44 miles. So 12 kilometers is equivalent to 7.44 miles. Now, the next thing that we need to do is say, okay, step 2. We now need to use the speed formula. Oops. We need to use the speed formula to find the amount of hours. So speed, remember, is distance over time. Okay? Speed equals distance over time. So we have the distance. The distance is 7.44 miles. No, I'm sorry. The distance is 26.2 miles is the actual distance. His speed we know it's actually 7.44 miles per hour. So this should be 7.44 miles per hour. My apologies. So we get 7.44 equals 26.2 divided by t. We need to find the amount of hours. Why does this keep doing that? There we go. So I actually need to erase this. Hours. We're trying to find the amount of hours. So 7.44 miles. Here we go. So we get 7.44 t is equal to 26.2. Divide by 7.44 on both sides. And we get t is equal to 3.52. So that means we're trying to find how long will it take? Well, it will take Alan. So we're going to say it takes 3.5, because it says round to nearest 10, 3.5 hours for Alan to complete the marathon. And that's it. Oops. All right, and that is your answer. Okay, moving on to question number 27. Here we go. Solve the inequality below. Nice. So we're going to subtract the 1.8 on both sides. We get negative 0.4. Negative 0.4y is greater than or equal to 0.4 minus 2y. I'm now going to add that 2y to both sides. We then get 1.6y is greater than or equal to 0.4. Now we're going to divide by 1.6 on both sides, and you get y is greater than or equal to, when you type that into your calculator, you get an answer of 1/4. So y is greater than or equal to 1/4. This is just one of those questions where you take the 2 points and run with it. Keep hitting that. All right, and that's your answer for question number 27. All right, moving on to 28. Here we go. Jacob is working on his math homework. He decides that the sum of the expression 1/3 plus 6 radical 5 over 7 must be rational because it is a fraction. Is Jacob correct? Explain your reasoning. Well, by now, just by knowing your perfect square rules, radical 5 is an irrational number. So if you were adding a rational and an irrational number, you're going to result in an irrational solution. So Jacob is wrong because the sum of a rational number and an irrational number results in an irrational number. Okay, because 1/3 plus 6 radical 5 over 7, this is rational. Yeah, 1/3 is rational, but this is irrational because of that radical 5. All right, because the square root of a prime number is irrational. So you can write that down. The square root of a prime number is irrational in this case. All right, and that is number 28. All right, moving on to 29. Here we go. Graph the inequality y is greater than 2x minus 5 on the set of axes below, and then state the coordinates of a point in its solution. So y is greater than 2x minus 5. Let's talk about this for a second. Let's analyze it. Your slope is 2. Your y-intercept is the point 0, negative 5. It is a dotted line, and it is shading above. because it is greater than. So all of that stuff accounts into what we're going to draw here. So it has a slope of 2, starting at 0, -5. So 1, 2, 3, 4, down 5. Go up 2 to the right 1, up 2 to the right 1, up 2 to the right. So you keep on going until you have no more room. Okay, and it is dotted. So I'm going to draw a dotted line. Actually, I'm going to do it that way. Okay. And, oh, shoot. I did that wrong. Oopsies. Okay. So here's our dotted line passing through all those points. And it is being shaded above. So in this direction. Make sure that you label that's y is greater than 2x minus 5. And that's it for that one point. Now it's saying state the coordinates of a point in its solution. So I said the point -1, 1 is a solution. Listen, if you picked any point that's up here is correct. If you picked a point either below or even if you picked a point on the line, you're wrong. It has to be inside of the shaded region. And it can't be on this line because that means that the point is not included in that solution set. All right, number 30. Sandy programs a website's checkout process with an equation to calculate the amount of customers will be charged when they download songs. The website offers a discount. If one song is bought at the full price of $1.29, then each additional song is 99 cents. State an equation that represents the cost C when S songs are downloaded. So the cost C of S is for songs downloaded. That's going to be $1.29 for the first song plus 99 cents times S minus 1. This S minus 1 or minus 1 comes up a lot on the Regents exam for Algebra 1. The reason why we're taking away 1 is we have to take into account that we already bought the first song. This $1.29 is your first song that you bought. So we need to subtract 1 to generate the 99 cent discount. Okay? And this, ladies and gentlemen, is your equation. It's C of S is equal to $1.29 plus 99 cents times S minus 1. Okay? Not too bad. Now there's a follow-up question. Sandy figured that she would be charged $52.77 for 52 songs. Is this the correct amount? Justify your answer. So we're just going to take our formula that we got. C of S is equal to 0.99 times S minus 1 plus $1.29. So we're going to plug in 52 in for S. So we get C of 52 is equal to 0.99 times 52 minus 1 plus $1.29. When you plug that into your calculator, just take my word for it, you get $52.70. No, I'm sorry. You get $51. You get $51.78. So obviously, $52.77 does not equal $51.78. So it says, is this correct amount? Justify your answer. We're going to say no. The correct amount would be $51.78. And we're going to say that Sandy is off by 99 cents. Chances are, if she's off by 99 cents, she probably made the mistake of not subtracting that 1. So that could be that could be a reason. Okay. Question 31. A family is traveling from their home to a vacation resort hotel. The table below shows their distance from home as a function of time. Determine the average rate of change between the 2nd hour and the 7th hour, including units. Average rate of change, you have to know that means slope. So, slope is equal to the change in y over the change in x, which is the same thing as saying y2 minus y1 over x2 minus x1. So, we get the slope, which is equal to, let's see, 480 minus 140 over 7 minus 2. That is going to be 340 over 5. Now, when you plug this into your calculator, you get your slope that is 68 miles per hour. And that is the average rate of change, 68 miles per hour. And that is hours and miles. Miles per hour is the correct units. Okay, that is it for question 31. Moving on to 32. Nora says that the graph of a circle is a function because she could trace the whole graph without picking up her pencil. Mia says that a circle is not a function because multiple values of x map onto the same y. Determine if either one is correct and justify your answer completely. So, first and foremost, Nora is incorrect because she says that a circle is a function. A circle does not pass the vertical line test. It's not a if you trace the graph without picking up your pencil, it doesn't mean that it's a function. So we are going to say that Nora is incorrect because a circle does not pass the vertical line test. Therefore, it is not a function. Now, I'm going to show you just a quick sketch of a circle. So it could look something like this. A little sketch right here. Like that. Draw yourself a circle. Boom. And it fails it at 2 points. 1 and 2. A vertical line, it can only be 1 point. So a circle does fail the vertical line test. Now let's talk about Mia. Mia says that the circle graph is not a function. Is she correct with that? Yeah, she's correct. But then look at her reasoning. Multiple values of x map onto the same y value. Ladies and gentlemen, this question was difficult because if you wrote that Mia is correct, you're wrong. Mia is incorrect as well. They're both incorrect. And this is why. While she is correct stating that a circle is not a function, her reasoning is wrong. She should have stated there are multiple values of y that map onto the same x. And basically what that means is when it maps onto the same x, your x value does repeat itself. So that, ladies and gentlemen, is how you solve that question. That was definitely tricky because you had to know the definition of a function, and Mia was wrong as well. So they're both incorrect. All right, 33. Graph f of x equals the absolute value of x, and g of x equals negative x squared plus 6 on the grid below. Okay, so we're going to do that first. So I'm going to put this over here. So f of x, my table of values for f of x. You draw that right here. Okay. So I'm going to go to my calculator. I'm going to type in these functions. So we get the absolute value of x, and we get negative x squared plus 6. Let me get that. So Control T, I'm going to I'm going to write down my absolute value equation. Sorry, not equation. Your table of values for the absolute value equation. So I'm going from -3, -2, -1. I need to zoom in. My head's probably going to be in the way. I promise I'll move my head. -3, -2, -1, 0, 1, 2, 3. And we get -3, -2, -1, 0, 1, 2, 3. No, I'm sorry. That doesn't make any sense. No, I'm sorry. That should be positive. Sorry. That should be +3, +2, yeah, I don't know why I wrote that. My apologies. +3, +2, +1, 0, +1, 2, 3. Now, g of x, which is your parabola, that is going to be these values. Well, the vertex is at 0, 6. So I'm going to go 3 above, 3 below. So -1, -2, -3. That's going to be -3, 2, and 5. 1, 2, and 3. We get 5, 2, and -3. So now what I'm going to do is I'm just going to graph these functions on my grid shown over here. All right, let's do that right now. Make sure that you label. This is your y-axis and your x-axis. And I'm going to graph the red one first. So -3, let's see, over here, boom, boom, boom. I'm just going to do this pretty quickly because absolute value functions are very easy to graph. Make sure that you have arrows on the ends of the absolute value graph as well. So, let's see here. I'm going to do it in red. Oh, that is way too big. Hold on one moment. That's better. Okay, so that's your absolute value function. And your g of x, let's see. This is g of x. Just like this. Oh, shoot. Alrighty, so this is g of x. Okay. Fantastic. Label everything, you're good to go. Now, if you want to circle the solutions, that's fine, but look, it's already asking, does f of -2 equal g of -2? Meaning, at x equals -2, are they the same y values? And yes, they are. I know that the blue line isn't really matching up well, but these are the same values. So your answer is going to be yes, because the functions intersect at that x value. Done. All right, that is your answer to question number 33. Moving along, number 34. All right, 2 friends went to a restaurant and ordered 1 plain pizza and 2 sodas. Their bill totaled $15.95. Later that day, 5 friends went to the same restaurant. They ordered their 3 plain pizzas, and each person had 1 soda. Their bill totaled $45.90. Interesting. Write and solve a system of equations to determine the price of 1 plain pizza. All right, so I'm going to say let P equal pizza, and I'm going to let S equal soda. So your equation for the first one is 1 pizza plus 2 sodas, and that totaled $15.95. Then I have 3 pizzas plus 5 sodas, and that totaled $45.90. Now, we need to solve for 1 plain pizza. So what I'm going to do is I'm actually going to cancel out my S's to solve for P. So I'm going to multiply the top by a -5, and I'm going to multiply the bottom by a 2 to cancel out those S values. So distribute. We get -5P minus 10S is equal to -79.75. Then down here we get 6P plus 10S is equal to 91.80. Those S's cancel, so we get P is equal to, when we add these, we get $12.05. And that, ladies and gentlemen, is the cost of 1 plain pizza, $12.05. All right, that wasn't too bad. Moving on to 35. Tanya is making homemade greeting cards. The data table below represents the amount she spends in dollars, f of x, in terms of the number of cards she makes, x. Write a linear function, f of x, that represents this data. So if you want to, you could type this information into the calculator, which honestly, I would, because they don't give you your y-intercept. Obviously, you could just go to your regression table and just say, all right, well, this is x and this is y. And let's just go and type these in. 4, 6, 9, and 10. Now, listen, you could easily determine this by hand, but it's kind of far to go down to the y-intercept, so I'm going to just type these in. All right. Control doc, add a calculator, menu, statistics, stat calculations, linear regression. That's your x, that's your y. Click OK. Okay, so we have our information here. So your slope is 0.75, your b is 4.5, and your correlation coefficient is 1. All right, so I'm going to go right over here. And I'm going to say y equals mx plus b. Your slope is 0.75. Your b is 4.5. So it says write the linear functions, f of x. So f of x is equal to 0.75x plus 4.5. And that's it, folks. That's your y equals mx plus b. Not too bad. Now the next part says explain what the slope and y-intercept of f of x mean in the given context. So it's saying that she represents, right, so this represents the amount she spends in terms of the number of cards she makes. So what we're going to say here is this. The slope represents the amount of money in dollars spent for each card Tanya makes. Okay? And then the y-intercept represents a startup or a fixed cost. Either one of those is perfectly fine. You could say startup or fixed. And that is your answer to the this part of the explanation. All right, moving on. 36. Alex launched a ball into the air. The height of the ball can be represented by the equation h equals negative 8t squared plus 40t plus 5, where h is the height in units and t is the time in seconds after the ball was launched. Graph the equation from t equals 0 to t equals 5. So what I did for this graph is I actually counted by 4 boxes. 1, 2, 3. I counted by 4 boxes. So that's 1, that's 2, that's 3, that's 4, and this is 5 over here. Okay, so basically I'm going to set up a table of values. So h of t. H of t, I'm going to set up an x and y table. Oops. I'm going to move my head here in a moment if it's in the way. All right, so we have here, we are going from 0 to 5. So 0, 1, 2. I'm going to plug in 2.5. You'll see why in a moment here. 3, 4, and 5. Now, if I graph this into my calculator, graph this as my calculator, negative 8x squared plus 40x plus 5. Enter. Okay. Control T, I'm going to get my values. And as you notice here, folks, between 2 and 3, 2 and 3 is the same value. The y values are the same. So that means that there's actually a higher point in the middle. So what I'm going to do is I'm going to do menu, analyze graph, maximum, click before and after. And your maximum is actually 2.555. And that's why I put, for here, that's why I put 2.5. So your 0 is 5, your 1 is 37, 53. Oops. This is 55, this is 53, 37, 5. So now from here, I'm just going to go ahead and graph this. So I'm going to count by 3s here. So this is 10, this is 20, this is 30, 40, 50, and all the way up here is 60. Okay, so I'm just going to go ahead and graph this. So 0 at 5, so it's about here. 137, that's around here-ish, somewhere around there. 2 is 53, somewhere around there. At 2.5, it's 55. So at 2.5, that's going to be 55. That's about there. I'm just going to repeat the process on the other side. All right. That is your parabola. I'm just going to try to draw a nice steady hand. It's kind of difficult on this software to draw a nice clean curve. So my apologies that that is so incredibly shaky. Let me try to do it with my mouse. See if that works a little bit better. Nah, not really. That doesn't work a little bit better. Hold on a second. Let me try to redraw it because I'm such a perfectionist that it has to look somewhat good. All right, let me try a thicker pen because thicker pens usually results in a better graph. All right, that's the best it's gonna get. So this vertex up here, that's the point 2.5, comma 55, and I'm gonna label this as h of t. All right, now there's a follow-up question. State the coordinates of the vertex and we just found the vertex. The vertex is equal to 2.5, comma 55. And it says explain what it means in the context of this problem. This means, and remember that we are launching a ball, so this means that at 2.5 seconds after the launch, the ball achieved a height of 55. Did they tell me in feet? No, it just says units. Of 55 units. And that is your explanation to that question. All right. Moving on to the final question on this exam. Here we go. Ian is borrowing $1,000 from his parents to buy a notebook computer. He plans to pay them back at a rate of $60 per month. Ken is borrowing $600 from his parents to purchase a snowboard. He plans to pay his parents back at a rate of $20 a month. How about you get a job, kids? No, I'm just kidding. Write an equation that can be used to determine how many months the boys will owe the same amount. So I'm going to create two functions. I'm going to create what's called Ian's debt, because he does have debt now. He's $1,000 in debt. And I'm going to create, let's see, Ken's debt. Okay, so we get that. So Ian's debt is y is equal to $1,000 minus his $60 per month. I'm going to make that 60x. Oops. I'm going to make that 60x. Okay, now Ken's debt, that is going to be y is equal to $600 minus $20 per month. That's going to be x as well. So now what we get here is we're trying to figure out, write an equation that could be used to model how many months the boys will have the same amount. So set them equal. So 1,000 minus 60x is equal to 600 minus 20x. Ladies and gentlemen, that is the equation that you had to write. That shows the amount that they will both need to, or that shows how many months the boys will owe the same amount of money to their parents. Then it says determine algebraically and state in how many months the two boys will owe the same amount. State the amount they will owe at this time. So basically we need to solve for the amount of months. So 1,000 minus 60m, that is, sorry, not m, x, minus 60x, that is going to be 600 minus 20m. So I'm going to add the 60x, I did m again, because I'm thinking m in months, but I just want it as x. So add the 60x. So we have 1,000 equals 600 plus 40x. Now we're going to subtract the 600. We get 400 equals 40x. Divide by the 40 on both sides, and you get x is equal to 10. Now that's the amount of months. Okay? But it says here, state the amounts that they'll owe. So we're going to say that the two boys will owe the same amount after 10 months. Okay? Where they each owe, well, let's see, if we take $10 and we 10 months and we plug it in, let's just say we plug it in, so let's just say, I don't know, 600 minus 20 times 10, that's going to be 600 minus 200. They both will owe $400 at this time. So both owing $400, and that is your explanation. So They owe the same after 10 months. And each owes $400. Okay. That's it. Final question. Here we go. Ian claims that he will have his loan paid off 6 months after... Wait, hold on a second. Ian claims that he will have his loan paid off 6 months after he and Ken owe the same amount. Determine and state if Ian is correct. Explain your reasoning. So, 6 months after, that means this. So, the 10 months is the point where the two boys owe after the 10 months. So 10 months is how much time it takes for both boys to have the same amount, plus the 6 months. So Ian claims that he will have his loan paid off 6 months after. Okay? So this is after the fact. Ian is claiming that it will take him a total of 16 months to have his loan paid off. Well, let's see. Determine and state if Ian is correct. So if you take Ian's debt, which is 1,000 minus 60x, and you plug in 16 months, that's going to be 1,000 minus 60 times 16. This will be $40. That means if there's $40 after 16 months, Ian will still not have his debt paid off. So he is wrong. So we're going to say that Ian is wrong. He still owes $40. And that is your answer explanation. Okay, and that, ladies and gentlemen, is the conclusion of this video. I hope that it helped. Make sure that you hit that subscribe button down below and visit my website at www.nysmath3newsprep.com. There's a lot more Algebra 1 stuff on there, as well as math subjects throughout high school, in geometry, Algebra 2, and more to come. And that's about it. I hope to see you soon.